this lesson, we're going to talk about precipitate formation and prediction. And we're going to work through the problem that if silver ion is mixed with phosphate ion, what, if any, precipitate do you expect to form? So first, let's define precipitate. So a precipitate is a solid that's insoluble that forms from a reaction of dissolved species. In a solution. So there's two basic steps to solving this problem. The first step is we want to determine a formula for the uncharged compound. Because we know that our precipitate, being a solid, it's not an ionic species, or it's not an ion. So therefore, it's going to be uncharged. It'll have neutral charge. So there's an easy way to kind of set this up in a table. First, we're going to have our species. Then we're going to write their charge. And then out front, we're going to have a place for subscripts. So our first species was silver ion. We know that charge is 1 plus. We also have phosphate, which is PO4 3 minus. Its charge is 3 minus. Now, we know we want a neutral charge, so we want our charge to add up to 0, but right now it adds up to -2. So we need to change subscripts over here so that we get 0. So looking at this, we see that we need to have a +3 to match the -3. So if we put a 3 here and leave a 1 here, we're just going to rewrite our charges, so those aren't the ones we're looking at anymore. So we have a 3 plus, because we have 3 of a 1 plus silver ion, so we have 3 plus, and then we still have 1 phosphate. So we have 3 minus, and we'll get a 0 charge. Now we just need to write our formula from using the species and subscripts here. So that gives us Ag3PO4. Now moving on to step 2, we need to determine if this compound is soluble or insoluble. And the way we're going to do this is using our solubility rules. And our solubility rules for silver say that silver compounds are generally insoluble except silver nitrate or this. So, since we don't have either of these two compounds, we know it's insoluble. So therefore, and we're going to have Ag3PO4 silver phosphate precipitate forms.